We want to talk about three different types of skewness. And skewness is, again, the direction that the graph is being pulled. And so if we recall, when we were making these calculations, when we calculated the mean in this first scenario, when the value was 11, we had a mean of 6.5. But when we threw in the number 100, then our mean changed to 21.33. And so when we talk about skewness, what's mentioned is the data being pulled in one direction or the other. And the way we can look at this is in terms of the mean and the median's relationship to each other. And so in the way that, and it deals with those outliers. Okay, so remember we said that the mean moved all the way to 21.33. So the data had been shifted to the right because this number 100 is pulling the mean value to the right. So skewness is the direction that the mean is being pulled . Because it's which direction that mean is being pulled because of an outlier. So the mean is being pulled to which direction due to potential outliers. Doesn't mean that there is an outlier, it just means that there's potential outlier. All right, so if the mean is being pulled to the right, okay, so this is right skewed. If the mean is being pulled to the right, in other words, it is larger than so the mean is to the right side of the median. So that makes this right skewed. If the mean is being pulled to the left side, in other words, it's a smaller mean value and to the median, then it's left skewed because that outlier is pulling the mean to the left side. It's a smaller out. So again, think about this as being a number line. So the outlier is pulling the mean to the left side of the graph. So that means this is a left skewed graph. And then we have a symmetric graph in which both the mean and the median, so the mean and the median are equal to each other. We don't spend a lot of time talking about the mode in terms of skewness, and so we don't really have to worry about the mode. We're really referencing the mean's relationship to the median. Remember, the median is dead center, and the mean is either to the left of the median or it's to the right of the median, or they're identical to each other or closely identical to each other. So we can look at skewness by drawing a histogram. That's one way of doing it. We can also do it by creating dot plots. And we'll do that with this set of data in a minute because we're going to talk about not only skewness but also variation based on this set of information. So variation is the spread of the data, or how spread out the data is to the entire data set. So how spread out the data is to the entire data set. So let's suppose that we have a set of grades that were A, and maybe there's 2 B's, 1 C, there's no D's, and 1 F. Or actually, there's no F's. So let's just make it that way. So there's 4 A's, 2 B's, and 1 C. When we draw this out, along the horizontal axis is all our categories. So we can do this with categorical or quantitative data. So we have A, we have B, we have C, we have D and F. These are all the possibilities, okay, so the entire data set. And then here's a dot plot. So we're just going to put one dot on top of each other. So it's kind of a modified bar graph. So there's 4 A's, there are 2 B's, and 1 C. And so this has, we can either have high variation or we can have low variation. And low variation means that there is generally one peak. We can also say the data is centered around a specific value. Okay, in this case, it's the letter A. High variation would be fairly flat graph. Because the data is all spread out. So in this case, let's suppose we have a situation where we have telephone numbers, the last digit of a phone number. And so the last digit, let's say we have 4302, we have another 3, we have a 1, we have another 3, we have a 2, a 9, a 5, an 8, another 0, a couple more zeros, another 9, 2 more 1s. So this is, we're going to use the numbers 0 through 9. And then our dot plot this time, so there's 1 8, there's 2 9s, there's 1 4, there's 3 3s, there's 4 zeros, there's 3 1s, and let's see, there's 2 2s. So in this data set, we're using most of the data. Okay, we're just missing, oh, we have 1 5. So we're just missing a 6 and a 7. But notice that the data is all spread out. So this would be called high variation, where in our grade data, we're pretty much around the A. So this is very low variation because we're only using a couple of the letters versus all 5 possibilities. Okay, so now we're going to look at this data set and we're going to create a dot plot, which is a modified histogram for the data. And we're going to just round all these values to the nearest whole second rather than trying to graph each one of them. All right, so we'll look at this and we'll create those dot plots. And so I'm just going to start with this set 1. And so first of all, we're going to round to the nearest whole second. So we have 10, a 10, a bunch of 10s here. Guess these all are going to be 10. None of these round up because we could have done to the nearest 10th of a second. And then here we have, oops, that's also a 10. And we have some more 10s. But once we get to, oops, those two would be 11s because we're rounding now up. So this is 11. And some more 11s here. Now we have a 12. So in this case, there is very low variation. So if we were to make this dot plot, So we're going to use all the data. So we're going to go from, so this is time in seconds. And so we have 10, 11, and 12 because that's for both data sets. We used to combine that. And we have a whole bunch of 10s. Let's see, how many were there? There's 20 total numbers. So let's see. Okay, so there's our 20 10s, and that's it. Where in our other graph, for our second set, we have, again, 10, 11, and 12. Again, time in seconds. And label these. And this time we had 6 10s. We have 8 11s. And then we had 6 12s. So in the first case, we have very low variation. So this would be considered low variation. And in this case, we would have high variation. All right, and then if we talked about the range, so the range by definition is we can actually do two different things. We can either say it's the max to the minimum value, or we can subtract the numbers. So if perhaps we want to say, so the range in temperatures in Phoenix in July, I should probably say high temperatures, and that range goes from, say, 107 degrees Fahrenheit to 117 degrees. That's one way of stating it. So we can go from max to min or min to max, in this case going from minimum to maximum. Or we could say the range in high temps is 10 degrees Fahrenheit. So depending on how you want to explain information to people, it might be easier to give them the minimum and maximum, or the maximum and minimum numbers, or you might actually want to subtract the numbers to let people know what the variation is. So in this first set, our range is 10. In our second set, our range is either 2 seconds, or we can say between 10 and 12 seconds. So we can either say, for the first one, we could say it's 10 seconds. The second one, we can say it's between 10 and 12 seconds, or 2 seconds. So again, this is giving you high variation, where the fact that we only have one value for the range, that tells you we have very low variation.